Hello, Course 3 students, and welcome to our first lesson of Unit 2. So this is lesson 2.1. To be honest with you, for the most part, I'm going to try and go kind of fast through this video because most of this should be a review from things that you've learned in past years. And so I don't want to take up a ton of your time, and so let's go ahead and get started. We have our objectives, which are I can write rational numbers and equivalent forms. So we're going to talk about what are rational numbers in this video, as well as we're going to take 3 examples of changing these rational numbers between the different types of forms that can be a rational number. So let's go ahead and talk about rational numbers. So a rational number is a number that can be written as a fraction. That's the biggest thing to realize. It can be anything as long as you can write it as a fraction. The only big things about it is that where you're going to have the top part of your fraction and the bottom part, both are integers, as well as I can't have a denominator of 0 because remember, it's all fun and games until somebody divides by 0. So here's a little chart to help you kind of remember about rational numbers. So this part has all of what you consider your rational numbers. So you have things as actual fractions, okay? Remember, decimals can be written as fractions. That's something that we're going to talk about here today on how to change decimals to fractions, as well as anything that's like a whole number or an integer that can also be written as a fraction. And so that's why those are on your real or rational number sides. The opposite side are things that are called irrational, which we're not really going to talk about for the most part, but they're things with decimals that don't repeat. So in this case, you've got a 0.3 with a repeating. That's a rational number. But if I got, like pi, you can't actually write pi out as a fraction or a decimal. You can write it out as a decimal, but you're going to keep sitting there for the rest of your life writing it out. So those are just irrationals or things that aren't perfect squares. So like I don't know what times what would give me 17. What number times itself would give you 17? If that doesn't work, irrational number. But for the most part, we're just talking about our rational numbers, which is all this part of the chart. And what we're really going to do is we're just going to start by talking about our fractions, and we're going to talk about simplifying these fractions. So this is a skill that I know probably as early as 3rd grade. I know you do it in 4th grade as well. So let's go ahead and talk about our simplifying fractions. First thing I want to do is I'm just going to rewrite it as more of an actual fraction version because right now it's hard again for me to type up these. But typically what you want to look at is you want to look at the top number and the bottom number. If I'm trying to simplify, it means I want the smallest numbers that I can get, but still have an equivalent fraction, meaning that it still means the same thing. So I want to think, what could I divide 9 by that I could also divide 55 by? Now I can divide 9 by 3 easily. I think that's really the only one other than by itself. But can I do 55 divided by 3? No, I can't. And so, to be honest with you, this first one is as simplified as it can be. So that's all your answer is. Is that, or you can say can't simplify further. Or you could say something like already in the simplest form. That would work too. So let's look at B though, because this time I've got negative 24, 32. And really the negative, I usually keep with the top number. We'll just keep, it's gonna stay negative. We're just gonna think, what could I divide 24 and 32 by? Well, the first thing that comes to mind is 2. I could start off that way, but there might be something that's a little better. What if I divided the top and the bottom by 4? Let's see where that gets me. So whatever I do to the top, I have to do to the bottom. So now I'm just thinking negative 24 divided by 4. So using those integer operations. Well, negative 24 divided by 4 would give me negative 6. Keep that negative because it's one sign is negative, one's positive. And then 32 divided by 4, well, that would give me 8. I think I can still simplify it further. And so if you do this first step like I did, and it wasn't, maybe you could have gotten, we could have gotten smaller. But at the time, I wasn't sure if we could. And so that's okay if you start with something smaller and then, divide again. Because I can still divide out a 2 here. So I'm going to divide a 2 from the top and the bottom. Because negative 6 divided by 2 is negative 3. And 8 divided by 2 is 4. And that's the smallest I can go. I can't divide anything that I could divide 3 by and 4. Like 4 I could divide by 2, but I can't divide 3 by 2. So this is my final solution. So again, getting it down to the smallest version of those numbers, but it still means the same thing. If I plugged this in a calculator and did, okay, negative 3 divided by 4, I'm going to get a decimal of negative 0.75. As well as if I put this in the calculator, negative 24 divided by 32, you'd also get that same decimal. They mean the same thing. This is just written in the simplest form. Alrighty, so one thing, like I said, we're going to talk about where you're simplifying fractions. So expect on your assignment today, there's going to be simplifying fractions. Second part then is also writing decimals as fractions. And I actually really enjoy writing decimals as fractions because I think it's easier than going from decimals, or writing decimals as it's easier than going from fractions to decimals. So write each decimal as a fraction in its simplest form. So the first one I'm going to look at right now, I can tell is I've got negative 5.59. This negative 5 is a whole value. So we're going to make this already a mixed number of negative 5 something, okay? So I'm going to have a different part of the fraction. I'm not going to make this whole thing the fraction. The easiest thing to think about is thinking about your decimal places for this, okay? So if I was, let's just make like 1, 2, 3, 4. This 1 in this decimal is your tens place, or tenths, sorry. The 2 then is your hundredths. And you'd keep going, okay? So 10, hundredths, thousandths, 10,000ths, so on. So now that I'm looking at this, I'm going to take this fraction part. That's going to be the numerator of my fraction for now, until I can figure out if I'm simplifying it. And then I take the place value that last number is into the right, and that is the hundredths, so I'm going to put it out of 100. Now, if I think about this, you can divide, I don't think I can divide this by 5. I don't think it works easily with a 3. Is 59 even a prime number? Alexa, is 59 a prime number?
Yes,
59 is a prime number, so that means I can only divide it by 59 or itself. And so this is actually the simplest version of my fraction. So here's my answer is negative 5 and 59 hundredths. So this next one, you've got one way you can read it, there's different ways. You got 0.5714, or you can say it as the, what would you say, 5,714 10,000ths. That's crazy. So I don't have a number in front. So that means I'm not going to have a mixed number. I'm going to have a fraction version. And I'm going to take this whole part that's beyond the decimal, and I'm going to place it out of this last place value that 4 is in, which I had just said. So it is the fourth place. The fourth place, if I kept going tens, hundredths, thousands, 10,000s. So I need to put 10,000 on the bottom. Whew. Now, given that I have a 4 here, I know for sure that I can divide by 2. So let's go ahead and do that to make it in the simplest form, because our directions also say I want it in the simplest form. So let's divide out a 2 on both the top and the bottom. Well, the easiest thing to do is that 10,000 divided by 2, which ends up giving me 5,000. All right, and then if I'm going to divide out 2 here, so All right, we'll divide out my 2. We can do the long way. 56 would be 25. Oh, wait. Well, 5 and, okay, so let's start here. 2 minus 4, okay, 1, 17. You can get, you can get 8, because 16. Then you bring down 1 and 1, and then you can get 5. And then you'd be left with 1 and 14 and 7. All right, so then in theory you'd have 2,857 out of 5,000. And I think that's the furthest I can go now that I have something with an odd number afterwards. You can keep checking, but I'm pretty sure that's as far as simplified as I can go. Alrighty, and one more version of this is writing your fractions as decimals. And so the easiest way to do this is using that long division that I was just doing, okay? Because for this unit, we're not using calculators. No calculator. This is something that you should be able to do on your own here. And so we're going to go ahead and I'm going to set this up as a long division because really it's saying 5 divided by 4. So that means I'm going to have 5 in the center, 4 out here. And we're going to add some decimal places after the 5 because in theory I can add as many zeros past 5 as I would like as long as I've got this decimal place. It's still going to mean the same thing. So let's see how far we can get with dividing. So I want to think 4 goes into 5. How many times? It goes in 1. 1 times 4 is 4, so I'm going to subtract 4. I'm left with 1. I'm going to bring down that 0. Now I think, okay, 4 times what is close to 10? In this case, I'm going to still make sure that that decimal's in the right spot too. So this stays here. So then 4 times 2 is 8, which is pretty close. 2, keep bringing down the 0. Oh, but this time, 4 times what gives me 20? That's 5. And so I end up with no remainder, and that's how I know when to stop to find my decimal. Okay? Let's look at B. I'm going to bring B over this way. Again, I'm going to set it up. I have -1. Oh. So let's keep it as just 1 on the inside. Remember, I can put as many zeros after the decimals as I'd like. And we're going to have it as 6. We're just going to make sure that my answer is negative. Because remember, a negative divided by a positive is going to give me a negative. So starting off, I can't do anything with that 1. So that's going to show me I have a 0, and then I'm going to keep that decimal place. From there, I can pretend that this decimal place is gone in a sense and think, okay, how about 10? 10 times, or 6 times what gives me close to 10? Well, 1, so I'm going to get rid of this. So now I have 10 divided, or minus 6, which is 4. Let's bring down this next 0, so we have 40. 6 times 6 I know is 36, so let's go with that. And then I have another, 40, and bring it down. Oh, do you notice now I'm going to keep going with 6, and I'm still going to keep doing 30 minus 36, and it's going to keep going and going and going. So if I'm going to write this out then, I would say that my solution is negative 0.16 repeating. If I kept doing it, it's just going to keep going and going. So in mathematics, we like to put that little line over it to just show that that's going to be a repeated decimal. All right, and that is the end of this video. So make sure to, if you are watching this in my other classes, make sure to submit it. Otherwise, another class, you're just going to watch it with me. From there, then it'll be working on that assignment and practicing those problems. Otherwise, I will check you guys later. Bye.